Hey guys, welcome back from your 3-day Memorial Day weekend. Um, Hopefully, none of the three seniors that we had in the class are actually watching this. And so that leaves you with five. There's just five of you, and looking at the grades and everything like that, I've got two A's and B, and then I got two others. So let's get all five of you up in the A and B area, and let's finish this class out strong. All right, today all I'm going to want to do is go over the homework problems from that you were given last week, 8.1 and 8.2. 8.1 was relatively straightforward. Most of you did pretty well there. There's just two things that need some clarification. The first off, when do you use a one-tailed test and when do you use a two-tailed test? Just for a better clarification, one-tailed test that is when you have an inequality in the HI. It indicates just one possible direction. Either right or left tail. Two-tailed that happens when you have not equal to in HI. That also it indicates two possible directions. Okay. Just wanted a little bit more clarification there. You will do HI based upon your in directions. Okay, if it's an inequality like greater than or less than in your HI, then it's one-tailed. If it's not equal to an HI, then it's two-tailed. That's the easiest way to tell. It's always in HI. Okay. Remember, there will never be an equal sign in HI. Equals will always be in your HO. Okay, and then the last question that I gave you was the question about the z-table to find the critical values. The biggest thing that several of you had a problem with was the two-tailed parts of the test. If it was one-tailed, you guys were fine. If it's two-tailed, please remember that you have to take your alpha and divide it by 2. So for example, number 10A, you were given alpha equals 0.05, and you were doing a two-tailed test. Well, if you're doing a two-tailed test, that means that alpha has to be split in half because you want half of it on the right-hand side and half of it on the left-hand side. So that means that alpha in this case is going to be, we're going to do alpha over 2, which is going to be 0.025. Several of you were actually using the Z chart, which is fine, but you can also use the same shortcut that you had before. You can use table C. Just go down to the infinite degrees of freedom. So if you look at table C and you have 0.025 and go all the way down to the bottom, you see that you have 1.96. Now, since this is two-tailed, it's going to be plus or minus 1.96. And just to prove to you that you can use this table, here's B. Okay, alpha equals 0.01, and it is a left-tailed test. Okay, so guys, just a quick little sketch. A left-tailed test would be this end, right? Because that's left-tailed. So that means that my z is going to be a negative. So all I have to do, if I go on my chart to 0.01, I see the number 2.326. Okay, well, if it's left-tailed, it's going to be negative. Several of you looked on the other chart and got negative 2.33. Both of them is fine. I'll take either one of them. I'm just letting you know that you can use that t-table to find these z-scores pretty easily also. And this one actually makes it a little bit more accurate for you. So if it's a right-tailed test, then the z-score is going to be positive. So then this number is going to be a positive 2.326 or 2.33. But remember, if it's one-tailed, you have to tell me if it's positive or negative, and if it's two-tailed, you have to give me both positive and negative. Okay? All right, so next. The 4 problems that you were given from section 8.2, lots of difficulty with these, so let's go ahead and go through them. Let me get something together here real quick. Okay, so first off, number 4, this is the PhD students. Okay? It says, full-time PhD students receive an average salary of $12,837. So that gives me mu is 12,837. Okay. The Dean of Graduate Studies at a large state university feels that PhD students in his state earn more than this. Okay. So that's going to be helpful. We've got HO and HI. So HO would state that mu is equal to 12,837. HI, if it says more than this, would say that mu is greater than 12,837. Now, if you want to get technical and make this less than or equal to, that's fine. That'll help you realize that this is going to be a one-tailed test. Okay. Now, also, this will help you with your claim. Which one is your claim? Well, your claim says it's going to be greater than, so that's my claim. Okay. So, we've got a lot of information already, and we haven't gotten in depth too much. He surveys 44 randomly selected students, so N equals 44. Okay. And finds their average salary is $14,445. So that means that my X bar is $14,445. The population standard deviation, so it even says the population standard deviation of sigma is equal to 1,500. And we're given alpha equals 0.05. Now, I did not tell you this, so I wasn't looking for it. I was basically trying to give you 4 problems to see, okay, can you do the problems? I didn't mark you wrong if you didn't do it. But guys, this is your official notification that you have to do the conditions for these problems. You must get used to finding out why you're doing these conditions and what you're testing for. Okay, you have to see if you can actually do the problems. Okay, so I'm going to go ahead and do the conditions even though I didn't tell you that you had to, just to show you that some of you are still having problems with the conditions. Okay, so I'm going to write down conditions. Okay, first, SRS. This is a random sample. Okay, it clearly says so in the problem. He surveys 44 randomly selected students, so that it means it is given. You don't have to assume, it is given. Okay? Now, what's next? Next is normality. Sorry, next is independence. Okay, how do I check for independence? Okay, well, we have 44 is n. Do we have 10 times 44, or is the population greater than 440? Yes, there are more than 440 PhD students with jobs, I'm sure. Okay, and then what's next? Next is normality. So you either have to be told that's a normal distribution, or n greater than or equal to 30. Well, we have what? We have 44. So n is greater than equal to 30. So 44 is greater than equal to 30. So our conditions have been met. Okay. Just get used to doing that process over and over and over again, guys. It will help you. All right. So I'm going to erase the conditions part because I want to get to the problem part. And I'm going to do the conditions for all 4 of these problems. I'm going to do all 4 of these problems on this video, and that's all we're doing today. Okay. Now, so first step, HO and HI. We've already done that. HO is mu is less than or equal to 12,837. HI, mu is greater than 12,837. Notice that you were given a population standard deviation. Okay? I'm telling you right now, you can't forget things that you were taught in the past. A population standard deviation means that you can use a z-score. If I have a sample standard deviation, what does that mean? That means that I have to do what? Use the t. All right. Anyway, let's move along. Let's draw our picture. Guys, some of you are you've got to tell me what your critical values are. Some of you are just like, saying it's in the critical zone or it's not in the critical zone. How would I know if you don't tell me what it is? Draw a picture, okay? I know it's difficult with the computer this time, but this is going to be a right-tailed test because it's greater than, so we're going to do this. If I have alpha equals 0.05, okay, that means I have a 1.645 is my critical value. You must tell me what that critical value is. If you don't tell me what that critical value is, you are going to lose points. Okay? I'm sorry, it's just that I can't change it. All right, so then you have to find your actual z-score. So what is the z-score? Some of you are still doing this backwards. Observed minus expected. Observed is the 14,445. Minus the expected, well, the expected was mu, so that's 12,837, divided by sigma over the square root of n. Well, sigma is 1,500 over the square root of 44. Now, 2 decimal places, please. This is going to be a positive number, so it's going to be 7.11. That is clearly in the critical region, correct? It's more than 1.645, and anything above 1.645 is critical. So, if it's in the critical region, this is the way that you have to give me the answers. Don't just tell me it's in the region, it's not in the region. This is what you need to do. You have to make a decision. Are you going to reject the null, or are you going to fail to reject the null? In this case, because it's in the critical region, we are going to reject the null. So you need to write reject the null. Okay, now we need a conclusion. Therefore, that's what these 3 dots mean, therefore, we have, if you reject the null, then you have enough evidence. If you fail to reject the null, then you don't have enough evidence. We rejected, so we have enough evidence. At what level? At alpha equals 0.05 to, again, our claim was HI. Since we claimed HI, that means that we are going to support whatever this is. Okay, remember, we we reject the ho and support the high. Okay, so if our claim is hi, we're going to support. Now, what are we supporting? What is the problem saying? What was the claim? That PhD students in his state earn more. The conclusion is very, very formulaic, guys. You do it over and over and over the same way, and all of a sudden you'll be like, oh, okay, I get this. All right. There's really only a couple things that really change, and then you have to be able to tell me what we're even talking about. That's actually the part where students mess up the most, and it's like, guys, just read the problem. Okay, so now let's go on to number 2. Okay, I don't know why I said number 4. Well, I know why I said number 4, but for you guys it was number 1. Number 2 for you guys. Okay, this was the peanut production in Virginia. This is the one that you all did the best on. Okay, so let's go ahead and write down what we've got. The average production of peanuts in Virginia is 3,000 pounds per acre. So that means that mu equals 3,000. It says the average is. Okay. A new plant food has been developed and is tested on 60 individual plots of land. So N equals 60. The mean yield with the new plant food is 3,120 pounds of peanuts per acre. So X bar, the observed, this is what you see by doing this test, is 3,120. So tell me, you should be able to tell me right now whether our z-score is going to be positive or negative. Hopefully you say, oh, it's positive because the observed minus the expected is going to be positive. Okay. Again, some of you are giving me negatives when it's got to be positive. It says the population standard deviation is 578 pounds. So sigma equals 578. Okay. At alpha equals 0.05, so alpha equals 0.05. Can you conclude that the average production has increased? Okay, so let's do our conditions first. Okay, again, conditions need to be done for these problems. SRS. Okay, let's read it. It's tested on 60 individual plots of land. Okay. What would you say? Would you say that it's given, or would you say that you have to assume it? Well, it doesn't say that it's random plots of land, so you would need to assume. Okay. Now, independence is the population greater than 10n. So do we have, is the population greater than 600? Do you think there's more than 600 plots of land that have peanuts grown on them? Probably. So yeah. I mean, this is one of those ones you don't know, but you know, we're going to say that there are. And then normality. Okay, either you're told that's a normal distribution or n is greater than or equal to 30. Well, is 60 greater than or equal to 30? Yes, so we're good. Our conditions have been met. Now we go into our problem. First thing we always do, HO and HI. HO. HI. Okay, so we know that mu is equal to 3,000, and we're looking for and we want to know if it's greater than, so we're going to say less than or equal to 3,000 for HO. If you just want to write equal to, and because of that, that's fine. Just make sure that you don't assume that the next part is not equal to. HI says we're looking for greater than, so it's greater than 3,000. Which one's the claim, guys? What are we claiming? Well, we're claiming that it's greater than, so the claim is HI. You have to identify your claim. Some of you aren't doing that. And again, we have our picture. Draw the picture, guys. Sketch it out, whatever you need to do. Our critical value with alpha equal 0.05 is, again, 1.65. I'm sorry, it was 645. Why is it 1.645? Well, I mean, this is the exact same problem as last time with the greater than, okay? So our z-score. Our z-score is going to be positive, guys, because, again, observe minus expected. Please, there's two of you specifically that keep getting this backwards, and you got to get it right. 3,120 minus 3,000 over the square root of 578. Notice that sigma is given. I'm sorry, not the square root of 578. I'm trying to do too much trying to go too fast. Okay, 578 over the square root of 60. Okay. And guys, if you're having problems with these formulas, they're right on your blue sheet. Okay. So our z-score in this case is going to be 1.61. Very important, very close, isn't it? Is 1.61 in the critical range? No. Okay, so if it's not in the critical range, then we fail to reject the null. And you have to write that, fail to reject the null. Okay. By the way, if we fail to reject something, what type of error are we opening ourselves up to? A type 1 or a type 2? Okay. Just think about that for a minute. So what's our conclusion going to be? Do we or do we not have enough evidence? Well, if we fail to reject, then we don't have enough evidence. So therefore we do not have enough evidence at alpha equals 0.05 to, again, we reject the ho, support the high. So this is HI, so we do not have enough evidence to support that the new plant food increases production. Okay? That's it. That's that problem. Okay? So we've got 2 of the 4 problems done. Okay? Notice again, sigma was given. Okay? So we're doing a z-test. I can guarantee you, hopefully you can figure out what's coming tomorrow. What's going to happen tomorrow is, what if sigma isn't given? Well, then guess what? We're going to do a t-test. But anyway, let's go ahead and do these other 2 problems so that we're all on the same page. Question number 3 was the salaries of government employees. Okay. So our government employees, it says the mean salary of federal government employees on the general schedule is $59,593. So guys, is that X bar or is that mu? That is mu, okay? Mu equals 59,593. Okay, next part. The average salary of 30 state employees who do similar work, okay? So N equals 30. Is 58,800. So X bar, because this was observed, This is our sample our sample mu. Our sample mean, sorry, not sample mu. 58,800, and it gives again sigma of 1,500. Okay. And in this case, we want alpha equal to 0.01. Can it be concluded that state employees earn on average less than federal employees? Okay. Conditions first. So I'm going to go right down here and do my conditions. SRS, it didn't say that it was randomly picked. It just says the average salary of 30 state employees who do similar work, so that's going to be assumed. Okay. Independence. Do you think there's more? Is our population greater than 300 of similar employees that aren't federal government employees? I would say so. And of course we have normality is n greater than 30 or equal to. So n is actually equal to 30. So we're good. Okay. All right, our conditions are good. Now, HO, HI. HO states that mu, now be careful here. The problem says, can it be concluded that state employees on average earn less than federal employees? If we're doing less than federal employees, then that means that our null hypothesis would be greater than or equal to the 59,593. And their HI would then be less than 59,593. By the way, guys, X bar is less than mu, correct? I hope you say yes. That means my z-score is going to be what? I'm going to have a negative z-score, right? This should lead you to thinking, oh, well, this is probably going to be a left-tailed test. And in this case, it is. So we have our picture. Okay. It is left-tailed. Don't forget to identify your claim. Your claim is HI. It is left-tailed. And at alpha equals 0.01, we go all the way down and we get 2.326. Negative 2.326. Again, guys, you must identify what your critical value is. If you don't do it, then how do I know if you got the right thing when you did your z-score? All right, so you have a z-score. Observed minus expected. So my observed was 58,800 minus 59,593 over 1,500. Notice it's sigma again, divided by the square root of 30. So our z-score is also negative, guys. Negative 2.90. So, in this point, I want you to think for a second. What am I going to say? Am I going to reject or fail to reject? Well, negative 2.90 is in the critical value, in the critical zone, right? It is less than negative 2.326. So we are going to reject the null. And guys, do you see why it's so important for me to see what your critical value is? Because, if you just tell me z is negative 2.90 and then give me an answer, I don't know if it's where it needs to be or not. All right, so we are rejecting the null. Therefore, guys, if you reject, you have enough evidence. Okay, so we're going to start that out. We have now, at what level do we have enough evidence? At alpha equals to 0.01. 2. Now, are we supporting or are we rejecting? Well, again, this is HI, so we are supporting. To support. Now all I have to do is figure out what we're supporting. It says, can it be concluded that state employees earn on average less than federal employees? To support, state employees earn less on average than federal employees. I know that I didn't show you a lot of example problems. I think I only showed you 2. But I'm hoping that you're starting to see the pattern of everything that you need to do. Again, I didn't say anything about the conditions. I wanted you to actually be able to do all the rest of the problem. But now that I have said that we need to do conditions, I'm going to go and I'm showing you these problems with conditions. Everything else needs to have the conditions, okay? Just I know I've said it before. I'm just trying to make sure that you're hearing me, because sometimes people have a tendency to zone out on these videos. Okay, last problem, and this is the last thing for the day. So number 10 was the home prices in Pennsylvania. This one you had to do a little bit of work, okay? It says, a real estate agent claims that the average price of a home sold in Beaver County, Pennsylvania is $60,000. Okay, so that means that mu is $60,000. Okay. A random sample of 36 homes, so n equals 36, is selected and the prices in dollars are shown, and I listed out all 36 of those for you. Is there enough evidence to reject the agent's claim at alpha equals 0.05? Now, I don't like the way the question's asked, but you'll see why in a minute. And what does it also say? It gives you it gives you sigma of $76,025. Again, all 4 of these problems gave you sigma, which means that you can do the z-test. Even though this problem you had to actually figure out what x bar was, it still gave you sigma. Now, ladies and gentlemen, y'all drive me nuts, okay? You have been given 36 data points. You can use your calculator and it'll give you a nice little average. How far can you take it? 1 decimal place beyond the accuracy of the data. The data goes to the ones place, so that means you can go to the tenths, and that's it. Should you go less than a tenth? No. Should you go more than a tenth? No. 1 place beyond. So your x bar, if you're very careful, should have been 82,495.8. That's it. Okay, you cannot go further. Some of you, now I understand because this is dollars and cents, some of you went to the cents. I'm not going to be too angry with you for doing that, but again, you're pushing it there, okay? And those of you that went beyond 2 decimal places, why? Why would you do that? You never should. Let's do our conditions. SRS. In this case, it's actually given, right? It says a random sample. Okay? Independence. Do you think the population's greater than 360 homes in Beaver County, Pennsylvania? I would think so. And then we have normality. Is n greater than or equal to 30? Well, is 36 greater than or equal to 30? Yep, we're good. So, let's do our problem. HO. Our null hypothesis is what the real estate agent was saying, is mu is equal to 60,000. Okay? Our null hypothesis, or alternate hypothesis, it's not saying, it says, is there enough evidence to reject the agent's claim? Okay, so we are looking for either higher or lower. It doesn't matter which one it is. So in this case, we're going to do mu is not equal to 60,000. Notice we're not asking for higher, we're not asking for lower. Also, which one's the claim, guys? It says a real estate agent claims that the average selling price. Well, the claim is HO. Lots of difference from this one from the other three problems, right? This one's our first HO claim. This also has an equal and not equal to it. Now, that doesn't mean that every time you have equal and not equal that the claim is going to be equal. And it doesn't mean every time you have an inequality that the claim is going to be HI. Okay? But that there's some differences here so that you can see these. All right, so alpha was 0.05. Okay? But since this isn't, you always go by HI to determine your critical values. It's a two-tailed test because it has not equal to in it. Now, alpha equals 0.05, but we have to divide that in two, so we go to 0.025, and we go down all the way down on our chart, and that's negative 1.96 and positive 1.96. Okay, let's get our z-score. Observed, that was our x bar, so that's our 82,495.8 minus the 60K all over sigma of 76,000 divided by the square root of 36. So if we're careful, we get a z-score of 1.78. All right, where's 1.78? Well, 1.78 is somewhere like around here. So is that in a critical area? Is that in a shaded area? No. So our decision is to fail to reject the null. In shaded, reject. Not in shaded, fail to reject. Okay. Therefore, okay, we reject, we have evidence. We fail to reject, we don't have enough evidence. We fail to reject, we do not have enough evidence. Okay, at alpha equals 0.05, 2. What is my claim? My claim is HO, okay? So I reject the ho, support the high. So my claim is ho, so I'm going to put the word reject here. To reject. Now, what are we rejecting? The average price of a home in Beaver County is $60,000. All right, guys, if you follow the formula every single time, you will never get it wrong. It's when you start trying to say, well, it sounds weird, and you start wordsmithing. That's when you start getting things wrong. Okay? So again, fail to reject, that means we don't have enough evidence. We always have to put the level of confidence that we're at. And then To. This word after the word to will either be reject or support. If the claim is HO, it will always be the word reject. If the claim is HI, the word will always be support. Okay? If you start trying to wordsmith it, you're going to get it wrong. You're going to mess it up. Just always do it this way. So we do not have enough evidence to reject that the average price of a home is $60,000 in Beaver County. That's it. Hopefully this makes sense to you guys. And then tomorrow when we go into T tables, it'll make a little bit more sense. Have a great day.